Good morning to all of you, and once again welcome back to my channel Steam Mechanical. Today in this video I will be focused on the resistance welding from competitive exam point of view. So let's start the video. For any type of competitive exams, this resistance welding is a very important topic in welding. Okay, so in resistance welding, basically in your any kind of competitive exam, they will be asked you the melting efficiency of resistance welding. Okay, you have to find out the melting efficiency eta m. So as you know that the melting efficiency is nothing but your heat required. Okay, heat required by heat generation. Okay, heat generation, so you can write it as hr, heat required by heat generation. So you have to basically find out what is the amount of heat you require to perform the resistance welding and what is the amount of heat generation is takes place after passing the current through the parent metal. So let first of all find out the heat generation. Heat generation is nothing but I square R T, where I is your current, or you can say the rated current. Okay, or current passing. Okay, current passing, and R is your resistance, and T is your time. Okay, so here unit is very important. Current unit is in ampere, resistance in ohm, and time is in second. Okay, now resistance welding topic is very easy because in your exam each and every data will be given, just you have to put by remembering this equation. So heat generation, if you are remember this simple equation, you can find out the value of heat generation. Let find out the heat requirement. Okay, this heat requirement you can find in two ways. Let first discuss about the first one, then I will be discuss the second one. First one is when the unit melting energy will be given. Okay, um is given. Okay, unit melting energy. What is the um? Now is your unit melting energy. Okay, so if in your exam questions unit melting energy is given, then simply heat requirement will be volume into unit melting energy, where V is your volume of nugget. Okay, volume of nugget. What is the nugget? Basically when the joining is takes place in between these two thin sheet kind of metal, there a nugget is formed. Okay, so you have to find out the volume of nugget, and to find the volume of nugget also each and every data, diameters, etc. will be given to you. So first one, to find out the heat requirement is your unit melting energy is given, and the you just have to find out the volume and then multiply with the unit melting energy. Now how to remember that you have to multiply the volume? What is the unit of this unit melting energy? Unit of this unit melting energy is basically your joule per mm cube, and we know the energy unit is joule or heat unit is joule. So if you convert this joule per mm cube into joule, then just you have to multiply with mm cube, then this mm cube get cancel out and joule will be remaining. Okay, so this is the one. Second one, to find out the heat requirement when the properties of the material. Okay, properties of material is given. Properties of material, which material you want to weld with help of resistance welding, the properties of that particular material if given in your questions, then you have to follow this one. Heat requirement. If you denote it by capital QR, then this heat requirement will be summation of your sensible heat, okay, sensible heat plus latent heat. Am I right or wrong? The total heat is the summation of sensible heat and latent heat. Now this sensible heat, how we can write down? mCp delta T. Delta T here your melting point temperature minus room temperature plus latent heat. Now if we consider the latent heat unit is in kilojoule or joule per kg, okay, carefully, your latent heat unit is kilojoule per kg, then we can take mass as a common. Am I right or wrong? This one is our kilojoule per kg, so we have to multiply by mass to get the total amount of heat. Similarly, from here also one mass will be present. I can take mass from both. So if in your exams questions latent heat unit is given as a kilojoule, this time don't take common mass, okay, because if you take common mass this times also, then mass will be multiplied 2 times, okay. So this time, so please take care about the unit of latent heat. Now this mass also you can write rho into V. So total, these equations will be your final equation, where this Tm, I'm write it here, Tm is your melting temperature, and Tr is your room temperature, okay. So up to this one is clear. In resistance welding, melting efficiency is very important. The equation or formula of melting efficiency is heat requirement by heat generation. Heat generations is simply I square RT, where I is your current passing through the electrode or the workpiece, and R is your resistance offered by the workpiece, and T is the time, okay, how much time you are allowed to pass the current. So unit, please remember the unit. Current should be in ampere, resistance should be in ohm, and time should be in second. Next one is heat requirement. You can find out the heat requirement in two way. When in your questions unit melting energy is given, then simply multiply unit melting energy by the volume of nugget. The unit melting energy unit is joule per mm cube. So if you multiply the volume, I mean mm cube, then mm cube gets cancelled out. You will be get the energy unit as a joule, okay, or maybe kilojoule. Second one, when the properties of material is given, which material you want to join, these materials properties are given, means density and the Cp, Tm, Tr. Tm is nothing but your melting temperature, Tr is nothing but your room temperature, Cp is the specific heat at constant pressure, okay, specific heat at constant pressure. So when all those properties are given to you, you have to just put in this equation and you can find out the value of heat requirement in your resistance welding. So this way you can find out the efficiency or melting efficiency. Now most of the time students gets confused that the melting efficiency is heat required by heat generation or heat generation by heat requirement. So please carefully listen. The efficiency should not be more than 100%. So we can say the ratio of these two should be less than 1. So as we know, heat generation is more because heat generation takes place and few amount of heat generation is dissipated to the atmosphere, then remaining heat basically used to melt the parent metal. So obviously heat generation is more than the heat requirement. So from here you can remember the melting efficiency is heat requirement by heat generations. So heat generation is always more than your heat requirement. If the value of heat generation is less than or equal to heat requirement, then what will be happened? Now the improper fusion of your parent metal will be takes place. So there will be defect welding will be generated. So this is total about your resistance welding. Simply remember this equation, what is the requirement of heat, and remember this one is very basics, I think, just multiplication of volume and this one. So remember these three equation and this one, then simply you can easily solve the question related to the resistance welding. So in this video this one is only. In next video I will be take examples in which I can show you that how to solve the questions by using these three equations. So thank you. If you get the my video is helpful for you, then please subscribe my channel and follow my video to upgrade yourself. Thank you.